Welcome to the session on Big Data and AI. I'm Sandeep Giri. I started my career in 2002 after graduating from IIT Roorkee, and then I joined a company called DE Shaw, where we had the systems which were running on petabytes of data, and we were running 10,000 node cluster when nobody else was. Okay, so that was 2002. Afterwards, I built a company called TBits Global. We built a document management system that's being used by many organizations on a large scale. Then I joined InMobi and Amazon, where I again worked on mostly humongous data and machine learning part. All right. For example, at InMobi, I built a recommender processing around 200 terabyte data. At Amazon, we were looking at building the mobile version of the Amazon detail page. That's the one that's being used. Okay. So, and after Amazon, I started No Big Data, which is now called CloudxLab. And CloudxLab is an environment for learning and researching on big data and machine learning. Okay. So again, welcome to the session. And so this session is going to be very introductory session. This is for the people who are getting started in this field. All right. So about CloudxLab, the learning with CloudxLab, you get videos, quizzes, hands-on projects, and case studies, and you also get a gamified learning environment. All right. Now let's get started. That's about CloudxLab. Let's get started. Great, great. So how many of you have played Mario before? Just raise your hand. All right. Wow, wow. Almost everybody has played Mario. Great, great. And how many of you have won the princess and reached the last level? How many of you have finished Mario? Wow, wow. So many of you have finished Mario. Wonderful, wonderful. And question is, how much time did it take you to learn? Okay. Now, the more important question is, did anybody teach you? Did anyone teach you? Did anybody teach you how to play Mario, or you were just handed over the controller and or joystick and you just started playing? Right? Nobody taught you, correct? You learned it by yourself. Great. So, can you imagine that it can be automated? Learning to play Mario or any similar game can be automated. Now, here, the demo I'm going to do is the demonstration I'm going to do is that the program is going to learn to play Mario by itself, the way you learn to play Mario, right? And what program is going to do is program is going to observe the game. Program is going to observe the game and it's going to press keys and then learn by observing the environment. Environment is represented like an image, and the game is this program is observing that image. The screen is in the memory and it's reading from the memory. So the program is going to observe the screen and is going to press the keys in order to maximize the game. The program knows where is the score displayed on the screen. This is something we have specified. Okay, so this person did the automation first in 2015. All right, so now what you're going to see is an interesting part. In the beginning, the program is just randomly pressing the keys and it's going nowhere. You can see these buttons here. They show which key are you pressing. So after a couple of more days of playing Mario, the program learns to play little better. It's moving forward and it's able to jump, and it's going to it's actually able to see few frames, but it's badly stuck, right? After few more weeks of learning, it is almost there. The program has by itself learned to play like us, at least like me. Okay, so you can see that it's able to play. This time it's able to jump through it. Do you think this he'll jump through it? Right? Do you think it'll jump? See, it jumped. So it's able to figure out and play by itself without having any problem at all. You can see it's able to play those expert moves now. After a couple of weeks, now it's able to play something really wonderful. What you're going to see is program exploiting bug. What was that? What was that? Let me replay. So here, the Goomba is jumping on Mario, but Mario just slightly moves down and kills it. So what program did was program kind of hacked Mario in order to win, right? So now you will see another bug is being exploited here. So the program has somehow figured out how to jump through it. Okay, it was able to stop falling. Again, in this particular game, it's not the same program was hooked, but the same program could not win it. But the moment it was supposed to lose, it just pauses the game. It keeps on pausing the game, and that's kind of intelligence. Remember the childhood days when um, your siblings could not win against you in the carom board or chess, and they will just come and spoil the game, right? Similarly, the program is continuously pausing the game because there was no way it could win it. Okay, all right. So did it make sense to you? Is it now? So what did we just learn? What we learned was program learned to play Mario by itself without any extra any extra um, steps, right? Without you having to tell the program that this is how gravity works, this is how you jump. No, the program figured it out. The program figured it by itself that how to win this game or win any other game without any need of extra programming. The only program that we had to write was the only program we had to write was how to interact with the game, how to observe and press keys. That's all we had to tell the game, tell the program, and rest of the learning was done by machine learning. Now, question to all of you is, to make this program learn any other games such as Pac-Man, we will have to, number one, write new rules as per the game, or number two, just hook it to new game and let it play for a while. Will we have to write new rules per the game, or just hook it to the new game and let it play for a while? That's right. That's right. And right? So number one is what we generally do in our daily jobs, that we write new rules as per the requirement and build the program or build the code. While with machine learning, we should be able to build these programs without having to explicitly write those. All right. So this is a real example, and this is in itself is more practical than you can think. This is actually quite a useful thing. Okay. Now, imagine doing the same for life. Imagine doing the same for life, gathering data and automatically solving problem. Why the program was able to learn to play Mario was two things, two aspects. One, we were able to gather data instantaneously. We were able to gather data automatically, right? As we press a key, the Mario automatically moves, and therefore we get a image and the data and everything. So gathering data in case of Mario was instant and available. While the reason why we are not able to solve many real life problems is absence of the data, absence of or availability of the data for various reasons, right? So we can do the same thing for the life if we have the data and the computation available. The second thing that was there was the programming, the computation, which so machine learning, computing ability, and the data, the three things made our program learn to play Mario. Correct? So this is an important part of understanding the understanding the machine learning aspect, that if you do not have data, if you do not have data, how will you apply machine learning? Okay, that's why the talk is called big data and AI. Okay, so the idea is to gather data and automatically solve problems. What do we need? What do we need? We need data and intelligence. And intelligence means artificial intelligence, and data means big data. All right. So, what is big data, everyone? The data of very big size that you cannot process with usual tools, and distributed architecture is required to process that kind of data. The data could be structured or unstructured or semi-structured. So that is the big data. Okay, so I'm not going to go into the definition of the volume, velocity, and veracity and variety. I'm going to just stick to this definition, that data so huge that you cannot handle with usual tools, or your computation on that data is so huge that you can't use the usual infrastructure, and you need distributed architecture. What does it mean by distributed architecture? Distributed architecture means you require Distributed architecture means you require multiple machines to solve a single problem. Distributed architecture means dividing your program or your computation onto multiple machines. Okay, so that's the big data. Now, for data, we need to collect, store, and process. For data, in order to achieve the previous screen where we said data and AI, data we need to first collect and then store and then process. All right. A question from Hashem is, let me just answer this question. The question is, can you give examples of structured and unstructured data? Structured data means the data in the tabular format, such as a database, right? In a database, you have rows and columns. And unstructured means the data where you don't know the fields, you do not know the columns, okay? And in order to infer some certain structure, you need to write program and infer it. For example, the data lying in your server logs is an unstructured data. Semi-structured data is also there, that's somewhere between structured and unstructured. That's some way between the structured and unstructured. Now, what does it mean by semi-structured data? Semi-structured data means the data in which we know the columns, but we do not know their data type. For example, the data in CSV is semi-structured. Also, we require some amount of processing in order to convert semi-structured data into perfectly structured data. That is semi-structured data. Great. All right. Great set of questions. The examples I've given for both the cases. All right. Wonderful. Wonderful. So for data, we need to you need to collect data, then store data and process data, right? So to collect data, we require IoT. We require IoT. What does it mean? Meaning that the IoT means Internet of Things. Okay, Internet of Things. So to collect data, we need devices such as phones, and we need connectivity such as Wi-Fi, 4G, NFC, and GPS. In today's time, the the magic that's happening right now regarding the machine learning is happening because of data. And one of the factors why it's happening is because of because of because of the connectivity as well as machinery that we have. Today's phone, the phone that you're holding, today's phone is more powerful than the supercomputers of 2002, right? The phone on which you play Auto Ninja or you play uh, the Subway Surfer, that phone is far more powerful than the supercomputers of 2000s. All right. So now coming back to the point, to collect data, we require the devices and connectivity. All right. And this is very much possible today. Today, there are all kinds of sensors. The sensors and the devices have become cheaper, faster, and smaller. Cheaper, faster, and smaller. You can see the phones. Phone has become cheaper, faster, and smaller day by day. And so are other hardware devices. That is the kind of performance indicator for most of the hardware companies to make the devices cheaper, faster, and smaller. Okay, and we are in a very good shape, good good state right now, where we have this wonderful device in our hand which can capture photos, capture sound, capture temperature, and capture all kinds of environmental data like movements. So coupled with the connectivity today, now the second part with respect to data is once you have gathered the data, you need to store this data. So you gather the data, transfer the data, and then you store the data. For storing the data could be any of these three. As I just described, data could be structured, semi-structured, and unstructured. Semi-structured, where we know the fields in the data, we know the data types, such as the data in a database table is structured. Semi-structured, we know the fields, but we do not know their data types. For example, XML or CSV. Unstructured data, we know the fields, but we neither know the fields nor we know their data types, right? In order to convert unstructured into structured, in order to convert unstructured into structured, we need ETL. ETL stands for extract, transform, and load. So this is where a lot of engineering goes in. And this whole ETL model changes when the data becomes big data. All right. Now, the other characteristics of storing data is volume, velocity, and variety. So you must have heard about it. So these are the three characteristics of the data that makes small data a big data, right? Suppose you want to store humongous data. In that case, if you hit, if your data is really huge, you would not be able to utilize, you would not be able to utilize your standard tools to store data. Therefore, even to store data, you would require humongous infrastructure, and you would require big data tools, right? Similarly, if your need to process data is really fast, the data is coming from many sensors, and you would like to you would like to capture that data in real time and process that data in real time. In that case, you would require ability to handle many requests coming at a very fast rate. Now, for example, think of Facebook being able to handle requests, billions of requests per minute. Similarly, YouTube and Google Analytics. All right. Third characteristic of data is variety. Variety means the data could be in many form. And this third characteristic is something very interesting. Something very interesting. Why? Because here, when we say variety, the variety also refers to the kind of problem that we are trying to solve. Why? Because 90% of the work is to be able to structure or process your data, right? For example, your data is in graphs and you would like to process it. It requires a lot of processing abilities. Similarly, you would like to create a hierarchical structure in your data. That's a humongous task to do. All right. So volume, velocity, variety combined together makes up the big data. Or you can say that if any of these characteristics of the data, whether volume, velocity, or variety, any of these three characteristics of the data could push you such that you require new kind of infrastructure. You require new kind of infrastructure that uses many computers simultaneously. Okay. And in other words, you can say that either one or more of these characteristics can make your problem big data problem. All right. So for storing data, the data could be unstructured, meaning you have to store the data in the files, or data could be structured, meaning you will have to store the data record wise. Okay. So there could be, generally, this is how we look at it. Okay. Semi-structured data is also kept in the unstructured format mostly, meaning in the form of files only. Okay. So now, generally, I'm just giving you very quick examples in order to um, give you a context. To store unstructured data, that is files, you could use either systems like HDFS or systems like Amazon S3 storage. To store structured data that is in the form of tabular, we could use systems like HBase, Cassandra, or MongoDB, or any NoSQL. All right. Now, if the data is coming up really fast, or generally when we deal with fast data, we deal with the fast data in the form of queue or but event bus. The data is coming continuously. There is no stopping of the data. It keeps on coming 24/7. It does not stop. That's basically fast data. And to handle fast data, we use the queues or buses, such as Kafka or Amazon SQS. Okay. Now, the second part about the data is processing. So we talked about few things. Let me just go back and give you a context what we're talking about. So we're talking about this screen. We're talking about collect, store, and process. To collect, you need the devices and connectivity. You need, and to store, you need to understand the data types. And these are the other characteristics of the data. And to store unstructured data, you generally use HDFS. And to store structured data, you use NoSQLs. All right. And to handle the fast data, the velocity of the data, we require Kafka or Amazon SQS like systems. Okay, the queues or the event bus. All right. Now, process data. What do we mean by process data? We talked about collect data, store data. Third part was process data, right? Collect, store, process. IoT, big data framework, and processing. Okay, big data storage, IoT, big data storage, and processing. Collect, store, and process. Okay, now what is processing? What do we mean by processing? What are we going to do with all the data that we have stored? We're going to process it. And when we say process it, what does it mean? Any instructions, whether we say take this data, break it down, or convert this string into a number, that's an instruction. Or an instruction can be as simple as that: pick this byte and increase that number by 1, right? That's an instruction. Okay, any instruction any instruction requires CPU. So any instruction requiring CPU is called processing. Bunch of instructions, billion of instructions combined together make up your program generally. Okay, it's measured by big O notation. Big O notation means how many number of instructions, how the numbers of instructions vary with your data, how the number of instructions vary with the data, or in other words, how the time taken to process depends on the size of your data. That's what big O notation means. All right. The the example of processing could be reading, writing, conditions, or jumping from here to there, as in if else conditions, or doing a for loop or while loop. All of that is the code, right? Code is an instruction. SQL, when you write SQL, that's also data processing. So to process data, you either write the code using any programming language, or you write the SQL queries or other form of computing. Okay. Third example of computing or processing could be the machine learning part. Machine learning is also basically the code or the instructions, just that machine learning, the big O, the complexity, the time taken by machine learning algorithms is really high. Even if data is very small, the total number of instructions could be really, really high. All right. Yes. So big O is kind of worst case analysis, and that's how we look at the computing generally. All right. So I think so. Yes, big O is kind of worst case computation, and in practical exam world, we generally look at the big O. All right. Now, to process data, to process data, we are oversimplifying a computer here. To process data, we need a computer, and computer in general is considered to have these many parts. CPU. In case of CPU, what does CPU does? CPU does the processing, meaning it executes the instruction and it executes the instruction. Instruction could be read the code, read the data from somewhere, or write the data, or it could be interacting with the devices, or it could be doing the if else condition, and so on. All right, that's instruction. So CPU does the processes the instruction, and meaning CPU executes your code. Therefore, the number of instructions that CPU can execute is very important. Therefore, CPU's speed matters. Second thing that matters in case of computer is, in case of your computer, is the RAM, the speed, and the size. The RAM, the speed, and the size. The RAM has The RAM is a place from where the CPU can read the data quickly and put it back. Therefore, RAM's speed as well as size matters. If the size is small, then you will have to store the data somewhere else, and therefore the speed will go drastically down. So the rate at which you can read from the RAM is also very important, as well as the size of the RAM. RAM means random access memory, which means CPU can jump to any any record in the RAM very quickly, any location that RAM very quickly and read the data. That's why RAM is used. The only downside of the RAM is as soon as your computer is turned off, RAM is kind of gone. The data in the RAM is gone. Therefore, you always keep the data in the disk. Okay, the third component in case of computer which matters for your computing is the disk. Disk is for storing data. There are multiple kinds of disk. There are hard disk or solid state. Solid state is fast but smaller and costly. Hard disk is slow but cheaper and bigger. Okay, so the size and the speed matters in case of disk. The fourth component that we keep on skipping all the time while discussing is network, right? If your network is slow, your most of the computing is going to get impacted. Why is it so? Why is it so? Because most of your program read the data from network. Or in other words, in case you're not able to fit your data in the disk, in case your data is not going to fit in the disk, you are going to put it in the network. All right. Therefore, all these four components are what make what all these four components matter to your computing. And any of these four components, any of these four components could make your any of these four component could become the bottleneck for your system, for your processing, and therefore you will have to move to an architecture where you can utilize multiple computers to solve your problem. Okay, now question to all of you is, which components impact the speed of computing? CPU, memory, memory read speed, disk size, network speed, or all of the above? That's right. That's right. Okay, wonderful, wonderful. Okay, so there are a few questions I would like to answer at this point. Okay, a question from Vedant is, can't we store structured data in a similar way like unstructured data is stored? Yes, that's very right. Yes, we can store unstructured way. We can store tabular data in the unstructured format. And as a matter of fact, that's what databases do. Databases store the tables in the form of files on the file system, right? But but the only difference is database knows exactly how to read it. Okay. The important part here is that if we are storing, let's say we have exported our structured data into unstructured way. For example, our data we just exported our data into space separated format, right, and kept it there in the files. So we are storing normal data in, say, space separated format, but when we want to process it, we will have to load it and then we'll have to load it into a system whereby we can run the queries, or we'll have to run the code in order to bring it to a level where we can execute SQL queries. Okay, in very simple word, structured data means we can process this data using structured query language. Structured data means you can execute SQL, meaning structured query language, easily. All right. Now, next question is, for processing data, any requirements is there? Any hardware? Yes. So most of this computing with respect to machine learning is very hardware requirement sensitive. We will talk about it further when we talk about machines in case of machine learning. All right. Thank you, Hashim. Good. Very good questions. Keep the questions coming. A question from a question is from Anup, is what is intelligence in scientific manner? Okay, so the intelligence is something which we are going to discuss further while we talk about machine learning. Okay, that's a decent amount of definition involved in machine learning. Okay, we'll talk about artificial intelligence, and then we talk about the definition proposed internationally by people. Okay, question is, sir, for big data, what is the hardware requirements for processing? In case of big data, we generally use a distributed computing system, and most of these distributed computing system are such that whether you upscale the hardware, meaning you increase or buy a expensive hardware, or you add one more computer in the network, the both have a similar impact in the computing. Okay, and this is being achieved by systems like Spark, so that whether you buy an expensive hardware or you use existing decent enough computer in the network. All right. So there is no hard requirement with respect to hardware, but you should have a good enough system. All right. Next question is the RAM size and speed example, right? RAM size and speed, as in the RAM you have is like, for example, this computer, the one I'm using, it has 4 GB RAM. Okay. Yes, that's right. And speed is, it's in really, really fast, as in RAM is around 20 times faster than your disk. Okay. Any example, are structured data complex? Not always, but sometimes. Complex is also by definition of your requirement. For example, let's say your data is very well structured in the SQL query, SQL table. Let's say you have a graph of people, meaning I am following you, you are following somebody. Let's say you have this graph of people in the database. Even though your data is structured, but the truth is, to process the graph, let's say to find who is most important, you will have to traverse the graph, understand it, and only then you'll be able to answer. So anything could be complex. It could be structured or unstructured. But unstructured, even for simple processing, you will have to first parse it and process it. Okay, parse it and convert it into meaningful, and then you apply queries on it. So unstructured is a little more complex than the usual one, even in the normal example. I hope I have answered the questions. These are very wonderful questions. Okay, there are a few more questions I will take, and then in the context of big data, which components will likely impact the cost? Okay, in context of big data, which components will likely impact the most? Arrange them in increasing order, and why? Very good question. So can anybody answer this question? All right, let me try. Let me try. Question is, out of these four components that we have talked, what is it that impacts the most? Okay, so those who have dealt with system engineering, they would realize that it's the RAM that hurts them most, then the disk speed, and then CPU. Okay, and then rest. Okay, so you can see, so the memory is something which is extremely costly, and the more memory you have, the better is your computing. All right, so you can test it out by either increasing the RAM of your laptop or adding a newer disk in the solid state drive into your laptop. You will get the answer. All right, good question, very good question. A question is, what are the other resources to collect data except IoT? Okay, so a good point, Raghvendra. So one is IoT for gathering the data. Other could be the usual forms of accessing the data over the internet, or or crawling the data and so on. Okay, so one is getting the data from sensors, and other could be the data from your existing sources, like the data stored in organization or data on the internet and so on. A question from Paul: could you provide some overview on algorithms that are used for machine learning? I'll be talking about it. Okay. Okay. What is the best way to start machine learning? I will talk about it very soon. What's the programming language needed with respect to that? Also, I'll talk about. Don't worry. Question is, I'm learning machine learning. Till now, we have dealt with numeric data. Is there any tool from which we can deal with the text data? Okay, so to deal with the text data, we generally need natural language processing or the usual tools. There are quite a few tools. If you take a look at, say, Stanford NLP or Bag of Words or Word to Vec, those are the tools or algorithms that you can use. Okay, all right. Big data is something that we should build. Big data is something that we should build databases like Oracle, SQL, or we should build it. A question is, what is big data? Big data is nothing but humongous data. It's not a processing, it's not a tool. It's a problem that's storing, handling the data. Okay, so specifically the data that you could not handle with your usual file systems or databases. So that means processing of unstructured data is more costlier than structured data. Yes, that's right. Okay, question from Naveen is, then what is the point of having unstructured data over structured? One is that it's not our wish that we want unstructured data. The truth is unstructured data is something you generally get, right? Second is, not every data can be represented as a tabular format. Okay, that's the reason why we call it unstructured data. The data could be hierarchical, the data could be in many formats, right? Therefore, not every data can be structured. Like, for example, video file, you can't really keep it structured. Okay, there could be complex scenarios. How to process unstructured data, since the data is not similar to others, on what basis we segregate it? That's the domain expertise we need to bring in. Okay. Sensor is most essential for IoT. Yes, kind of. Sensors or any devices that are connected and are over the internet and network. All right, good, very good set of questions. Question is, how do we collect data from IoT? Can you please give few examples? Or device name to receive and store data. So I think that'll be itself a huge session. So I think a better answer would be that either you write to us, come over to our forum. If you go to CloudxLab, there is a forum where you can ask your question. I would love to personally answer this question. All right. A question is, can efficiency of algorithm impact computing speed too? Good question. Good question, Pankaj. Let me take a step back and try to explain. I think others will be, finding it useful too. A question is, the, what does it mean by, overall time taken by a program? Is it a function of hardware or the program? The answer is both. If you have written an infinite loop in your program, No matter which hardware do you use, you will always get 100% CPU, right? Therefore, the efficiency of algorithm is far more important than the hardware. For example, can you guess what was the CPU of iPhone, the iPhone 3, the beginning model? It was 300 megahertz. It wasn't in gigahertz, and it was able to handle almost every task of the phone, right? Therefore, efficiency of algorithms is very important. All right. Efficiency of algorithms, the way you design the code, the way you process, the way you build your logic is far more important. And that's where most of the research goes. All right. All right. A question from Sweta. What's the form of data in the Mario game? It's mostly structured because here we are not using any structured language or representing the data in the form of table. It's basically array of data contained in the memory in the binary form. Okay. Good question, Sweta. All right. We are going to talk about machine learning soon. And okay, there is one more question I would like to take, and rest, I think I can take it later. Question is, today is the real challenge to in collecting the data or structuring the data to gain insight on? Okay, the answer is both. The answer is, question is, what is more important with respect to the data, or what's a real challenge? Is the real challenge in collecting or structuring the data? The challenge is in both. Okay. So converting raw data into structured is not always possible, but yes, that's a task, and it does help if you have great tools. But understanding the data and predicting and doing machine learning on that is even further more complex. Therefore, both are equally valid challenges. All right, great, very great set of questions. Keep the questions coming. Keep the questions coming. I'll be taking further questions after a couple of more topics. Okay. All right. So we talked about processing data. So far we have talked very briefly about collecting data, storing data, and processing data. We would like to go a little more deeper into processing data. So far, we've understood that what does it mean by a computer with respect to processing data, what does it mean by various kinds of formats of data. Now, the other thing we need to understand is what does it mean by parallel computing? Parallel computing is getting things done in parallel fashion. The first form of parallel computing is distributed computing. This is actually newer as compared to the other parallel computing. Other parallel computing was using multiple processors in the same machine. Okay, so to process data, people realized that the processors are not going really fast, as well as the hard disk is becoming the bottleneck of the computers. Therefore, it was important to utilize multiple hard disks or multiple computers having multiple hard disks in the network. And that's where the distributed computing became important. The distributed computing became important because CPUs were not improving much. Second, the disk speed was becoming the bottleneck. Therefore, to group a network of sorry so so distributed computing means that groups of networked computers interact with each other in order to achieve a common goal. In order to achieve a common goal, that's the important phase. That means that if you just are using network computers and all of you are anyway connected, that doesn't mean it's a distributed computing. Distributed computing means utilizing so many computers in order to solve a problem, right? That's distributed computing. Now, the other form of parallel computing is using multiple cores. One form of multiple cores is Gpgpu, which is called General Purpose Graphical Processing Unit. So when earlier when people were playing graphical games like really high-end graphics. So they they built the graphical processing unit. They were basically many cores bunched together in a single computer, like 20, 30 cores or hundreds of cores put into the same computer. Okay, and that apparently gave really good performance at that time for the games, right? Then people realize in case of machine learning that machine learning involves lot of maths, and which is very similar with respect to computing that was there in the games. And hence on GPU people found that lot of machine learning algorithms or artificial intelligence algorithm worked really well. So to process data, either we can use a single computer, the one which we described earlier, or we can use many computers connected, or we could use a GPU machine. GPU, you can buy a GPU card and insert it in your existing computer. Basically, GPU will have many cores and it will come with its own memory and will work fine. Okay, so GPU is basically this kind of architecture, many processors interacting with memory. The problem with GPU machine is the RAM that it brings with it, the memory it brings is generally very limited, right? So for example, as of now, the best available GPU is with 16 GB, not, and normal computer has a memory of say 200. If you can buy actually RAM up to 200 GB and more. While in case of GPU, the memory so far, which is commercially available, is around 8 GB of memory or 16 GB at most. So here, in case of GPU, even though there are many processors, but memory becomes a bottleneck very quickly. So many processors or core performs a task and interact using a memory or bus. That's GPGPU or multi-core kind of processing. All right. The other example, let's take a quick comparison, right? So multi-core is what? We always had these dual core, quad core computers. That's multi-core. GPU machine is the graphics driver, the graphics card that you put in your machine. That's GPU. Then the distributed. Distributed is like Spark or Hadoop connected in the network. So all three are parallel computing. All three are parallel computing. Okay, let's just compare all the three very quickly, because in case of parallel computing, we'll talk about this again and again. All right. So with respect to handling huge data, multi-core can't handle it, because in case of multi-core or GPU, in case of multi-core or GPU, it's the same hard disk, right? Same hard disk trying to read the data. Therefore, there is a limit. The disk read is the limitation here. While in case of distributed, since distributed involves many computers connected in the network, right? Therefore, you can read from many disks simultaneously. That's why for reading humongous data in parallel, distributed kind of parallel computing works well. So what we are talking about? We're talking about the ways of processing. First way of processing was using a single processor, right? In the single processor, you could only execute one instruction at a time. Okay. The second was multi-core, meaning you have multiple computers, dual core, quad core, etc. Then we had GPU. GPU means graphics card, and distributed. So why I'm talking about this is what will matter after a point of time. While distributed is great for humongous data kind of problems, GPU machines are great with the processing part of it. Okay, processing part of it. If your processing is complex, the GPU works well. If your problem is storage intensive, then distributed works well. Meaning, in case of distributed, Hadoop or Spark work well, while GPU, you will need to buy hardware. Okay, great. Next is, so it's all related to machine learning, Akansha. So please pay attention. We'll talk about all of those, Mohammed. Next is, If you really need a really fast communication between the CPUs, meaning let's say you have done some computation, you want to convey it to the other one, in that case, both of these are pretty fast. Both of these are pretty fast, right? Both of these are pretty fast because in case of distributed, the data transfer happens over the network. While here, the data transfer happens through the memory and it's pretty fast. Now, with respect to the playing games, like high-end games, the way you have Xbox and everything, with respect to that, GPU is far better, or doing lot of computing because most of machine learning is all about maths. Therefore, that part of the where you are executing a lot of matrix multiplications or other form of complex computation, GPU does pretty well as compared to the multi-core or distributed. Okay, so the tools that we use in this case to utilize multi-core, multi-cores can be utilized by the usual tools as well, Spark and Hadoop. Spark can utilize the multi-core very well to utilize or write the program which can exploit multiple GPUs. We use these kind of tools. Keras, TensorFlow, Cafe, and Spark also has come up with a GPU model. Third one is distributed. Distributed means if your data is distributed, you want to process it, you could use Hadoop MR or Apache Spark. Also, TensorFlow also has come up with a distributed model. They call it parameter server. Great, great. So let me go over this structure and then I'll take up your questions. Great. Now, so here we talked about few things. These are the frameworks to handle the data. Spark is for processing the data, specifically when your data is distributed, and TensorFlow, Keras, Cafe, and Spark. Spark is experimental. So if you want to do a lot of complex processing, you might go for TensorFlow because TensorFlow seems to do a pretty good job. And that's why we have picked up TensorFlow for our next course. Okay. Now, coming back to what is Apache Spark. Apache Hadoop is great for storing data and running any kind of computation in the network, but for processing data in a distributed fashion. What does it mean by distributed fashion? Using many computers you want to process data. Do the simple processing. Okay. You so you generally use Apache Spark. These are ecosystem of tools in Apache Spark mode. You have you have Spark Core. Spark Core is the heart of Apache Spark. Apache Spark is a framework that lets you use many computers simultaneously in order to solve your problem. Okay. In order to process big data, you can use Apache Spark. And to store the data we have already talked about, you can either use the cloud-based solutions or set up your own Hadoop cluster or any other storage in the distributed way. So while Hadoop lets you store the data in the network, Spark lets you process. Hadoop's MapReduce used to help you process, but Spark, Spark was far more faster. Spark is faster than the Hadoop MapReduce. Therefore, we generally use the Spark these days for processing. Now, coming back to it, so we had Spark Core. Spark Core was the heart of it, which can run on Hadoop, EC2, or Mesos or standalone. Let's say you have in your company, you already have a cluster. They're already using Hadoop in your company, right? And you want to use Spark. You can right away use Spark without the need to install anything in the network. Okay. Therefore, Spark can that essentially means Spark can run on top of Hadoop yarn. Okay. Similarly, if you are using Amazon EC2, then also you can run your program which you have written for Spark anywhere. All right, and so on. In case you don't have a cluster, neither Mesos, not Amazon EC2, nor Yarn, then also you can set up a cluster using Spark Core. right? So Spark Core, we can read the data from various sources, not only HDFS or HBase or Hive, but also from third-party systems. Spark can read data from all kinds of data sources in all kinds of formats, and you can mix and match the data. So you can see that you can process your data using Spark if your data is really, really humongous. Or, or you can run machine learning algorithms using Spark in a distributed fashion. Okay, and since you cannot keep on writing code, you have the next level of libraries such as data frames. Data frames allows you to create the data in structured format from, and then process data in the structured formats. Okay, so you can represent your data in the data frame in the tabular one and then run SQL. Or if your data is really, really fast, then you can use streaming. And then if your data if your data involves machine learning, then you can use MLlib. If your data involves graph processing, such as Facebook graph, like network of friends or network of nodes, finding path, those kind of problems can be solved with GraphX. Okay, so these are the libraries provided by Spark. Spark Core lets you do any kind of processing if you write the code. And that code can be written in Scala, Python, Java, R, or SQL. Okay, so you can interact with the entire ecosystem. You can interact with the entire ecosystem with many different programming languages. And this can read the data from everywhere, can run the logic on your cluster, whether you're using Hadoop's cluster or Amazon's cluster or Mesos, or you have set up your own. Okay, so this was an overview of processing data with Spark. So what we are talking about, we talked about three things: collect, store, and process. Collect means IoT or other places wherever you can collect the data from. Store means using a storage system. Then process means either using the machine learning kind of processing or using distributed computing, either using the GPU or dual cores or single machine, or using a distributed processing environment like Spark. Okay, so Spark basically distribute your data onto multiple machines and let you process the data. Okay, so imagine that you have a big table, right? Big table, and you want to run a query on this table. And this table is created from the data which is a terabyte in the size, right? So some of the records will be on one machine, second machine, third machine, formally, and these machines will be parallelly running your query. That's how you can always visualize it. So RDD, and the newer concept is data frame. So using the RDD or the data frame, you can use Spark in order to process data using multiple machines. Okay, so we are talking about third part, which is processing data, right? Now, this was about processing data. Okay, so we talked about a few things. We talked about that to solve most of the problems, we need data and intelligence. For data, we need to gather data, we need to store data, and to process data. For processing, we could use the Spark kind of infrastructure if your data is really humongous, such that you have to store it using multiple machines and process using multiple machines. Okay, if you want to use a single machine, then you can use any framework. If you want to use graphics, the GPU, okay, if you have to use the GPU, then maybe TensorFlow will be a better idea. Okay, if you have to do lots of maths and lots of graphics, TensorFlow will be a better idea as of today. All right, great. There is a couple of questions. Let me answer those questions, and then we will start with our AI. Okay. All right. Now, let me just go back to one more screen back. Yes. A question is, if Unstructured data like if unstructured data like image and contains numbers, can we extract and save in Hadoop? Yes. Is a video can be stored? Yes. If so, how Hadoop extracts data from it? So Hadoop wouldn't do much help. You will have to use some kind of input format, or you will have to use your own program to extract data from a video. All right. You'll have to run your own program. Great. Very good question. A question is, what's the difference between machine language and machine learning language? We'll talk about this. Okay. In case I'm not able, I forget to answer your question, you can ask again. All right. Question from Raghavendra is any combination of distributed and multi-core and GPU? Yes, you can also combine multiple machines together. Okay, but most of the programs can either take advantage of multi-core or GPU at the same time. Okay, because if you move between multi-core and GPU, you will be moving data from GPU's RAM to your normal computer's RAM, right? As I told you that in a normal computer, you can insert a graphics card. Graphics card will bring its own processor as well as the RAM, and and therefore the transferring data between the two RAMs will be time consuming. Okay. A question from Santosh is how data processed in RDD. For that, you need to write transformations and actions, and you can take a look at a couple of examples of Spark that we have talked about on our blog. Good questions. Great, great. Really, questions related to AI, I'm going to talk about now. Okay. We'll take the questions related to the AI in the second half, right? Okay. A question is, what is actions in RDD? You take a look at a couple of examples of, in the case of Spark, you will get the idea. Transformations do, kind of do transformations while actions do something. Transformation is an instruction to the to the Spark that you do something, while actions do something, right? Transformation doesn't get executed right away. Okay. All right. A note about programming languages. Seems to be a kind of lot of confusion with respect to programming languages. So most of the programming languages are good enough. Okay, good enough. Whether you are good with Java or you're good with Scala, you'll be able to use all of these algorithms. Moreover, 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 learning any of these programming languages is not a big deal. Okay, and all of the people who are attending this session today, my request to all of you is learn at least one programming language. Okay, learn at least one programming language. All right, whether you are a linguist, whether you are a lawyer, whether you are a manager, whether you are an engineer, whosoever you are, please learn at least one of the programming language. Learning a programming language is very important in today's time. All right, so I think you can start with Python as a programming language because that seems to be pretty simple and most of the work can be done using Python. All right. So moreover, in today's time, the language wars are kind of not there, right? You learn any language and most of the tools, the way they are being designed in today's time, they can be used from all kinds of languages. For example, TensorFlow from Google, the one which we talked about, the machine learning or AI tool, that the tool can be used from multiple languages. Okay. While While TensorFlow itself is written in C++, most of the people who are using TensorFlow are using it via Python. Okay. The more important part is both newer frameworks are trying to overcome the limitations imposed by variety of languages. Okay, so that instead of the work is being done by the caller's language, the work will be done by the underlying framework's language. Okay, so that's an important part to understand. So instead of, imagine that no matter what programming language you use with respect to database, you always use SQL, right? Similar is the case with TensorFlow. No matter what you do, you create the graph of TensorFlow. Similar to SQL, you basically structure all your thought into a graph and then give it to run. Okay, and yes, this graph can be prepared with R, Python, C++, or anything. So that is one of the most important thing to remember in today's time, that the language does not matter anymore, right? Because specifically for learning to get started. But language does matter when you're trying to create your own algorithms. And for creating your own algorithms, people choose high performant languages such as Scala or C++ or C or any other. Okay, so keep in mind that if you are trying to create algorithm, you might end up creating in C++, but to use any of these frameworks efficiently, you can use any of the high level languages, either Java, R, Python, or Scala, and so on. All right. I hope I have answered your questions. So most of the things can be done in most of the languages as of today. Okay. And that's the thing they are trying to achieve. Okay, say for example, when I worked on Hadoop for the first time, even though I came from Java background, I ended up doing everything in Python. Okay, entire recommender system we wrote in Python. All right, so that's just an example of, most of these languages can be used with most of these frameworks. Great. All right. So yeah. So whichever language you are coming from doesn't matter, but my request is at least get used to one language, such as such as the such as Python. All right, wonderful set of questions. Okay, all right. I think that answers your question as well. Okay, a question from Chetan: how versatile is our language? Every language can do everything, honestly, in today's time. The only advantage of R is a lot of people have written a lot of libraries for it. Okay, and those libraries are now available in other languages as well. So therefore, R is definitely powerful, but so are the other languages. Okay, wonderful, wonderful set of questions. Great. So let's talk about AI. So what is AI? AI is artificial intelligence, the intelligence exhibited by machine. I- The intelligence exhibited by machines. All right. So it's a very hard question to answer. As somebody asked in the beginning, that what is the scientific definition of intelligence? Okay. Let me talk about what is AI. All right. So the intelligence exhibited by machines, okay, or programming machines to exhibit intelligence, or modifying machines to exhibit intelligence. So machine by themselves don't exhibit the intelligence, we make them do so. All right. So what is AI? The theory and development of computer systems to perform tasks requiring human intelligence, such as visual perception, speech recognition, decision making, and translation between many languages. Okay, so you can see that anything. So the definition of AI is about around making machines do the things that humans do, such as visual perception, speech recognition, and decision making. The definition of AI is really hard to give because there are many aspects to it. It's hard to imagine it's hard to imagine intelligence. What does it mean by intelligence, right? Therefore, in terms of human way of looking intelligence is that somebody who can have visual perceptions like humans, someone which can have the ability to speak as well as recognize the voice. Similarly, the ability to take decisions and being able to do the translation between the languages. That's one of the definitions of AI. And there has been in mythology as well, all right? So from the historic perspective, human has been obsessed with creating mechanical man, trying to create a machine which looks like human and works like human, thinks like human and behaves like human. So there is a forever the human has been trying to do so. Even in probably every mythology there is one or the other character which looks like a mechanical man, right? For example, here in Greek mythology there is a mechanical man named Talos, right, as shown in the diagram on the left. So in the fiction novels we have Mary Shelley's Frankenstein, as well as, so there are quite a few fiction novels as well as movies as well as mythology where we have been trying to think about creating a mechanical man or trying to create artificial intelligence, right? Now, so the definition was, somebody had asked this question about intelligence. It's a hard to answer. And few scientists sat down in summer of 1956. And the term in that workshop at Dartmouth College in New Hampshire, the term was given by John McCarthy during a workshop, there, along with the colleagues Marvin Minsky, Claude Shannon, and Nathan Rochester. So they sat down and they came up with the definition of AI, definition of intelligence. They set down the purpose. They set down that this is what we should be working on. So they said they defined the sub-objectives of AI. They defined the sub-objectives of AI. Instead of trying to create right away, they first define that whatever we do under the umbrella of AI, it should be under any of these objectives. The sub-objectives of AI are creating perception, being able to, these were the five objectives. Let me go over quickly. Perception, being able to see. Reasoning, being able to mm, logically reason out things. Navigate, move, as in go from one place to another. Natural language processing, understand the voice, understand your text, and understand the language that you speak, humans speak. And represent knowledge. Represent knowledge. Okay, so basically, these were the sub-objectives of AI. All right, let me go over that. So what does it mean by represent knowledge? Understanding and classifying terms or things in the world. For example, what is a computer? What is a thought? What is a tool? So this is one of the sub-objectives of AI. To be able to represent knowledge, we need to build a system. We need to build a system that should be able to that should be able to represent knowledge. A computer should be able to itself say, define the computer, and it should be able to infer it and represent it. It should not be like human, somebody sitting and representing it. Okay. In the beginning, in the earlier era, people tried to create language representations. Lisp, a programming language, was created with this purpose, but it failed because by manually creating the representation of knowledge wasn't actually possible. Okay, there are many language proving tools or equation proving tools representing the various graphs, and they failed. Why? Because manually creating the representation isn't possible. So sub-objectives of AI is to be able to represent knowledge by itself. Next is reasoning, meaning being able to play complex puzzles such as chess, Go, Mario. Mario, the one which we talked about earlier, right? Our program was able to play Mario, right? Without us teaching the program how to what to do in case of the various situations, the program was able to take that reasonable call when to jump, when not to jump, which one to pick and which one not to pick, right? That's reasoning, being able to play puzzle games, prove theorems such as geometry theorems, right? Being able to play, prove something, prove an argument, prove theorems, prove geometrical theorems, that's reasoning. Or given various kinds of circumstances, it should be able to diagnose diseases. It should be able to learn from the past. And then given a patient, it should be able to diagnose what kind of disease does a patient have, right? That's reasoning. So first sub-objective of AI is being able to represent knowledge. Second is reasoning. Third objective of AI is navigate. Navigate, meaning move from one place to another. And moving in the real world is hard. It's hard. Being able to plan and navigate in the world involves many sub-objectives further. How to locate the destination, how to identify the destination, how to pick a path, how to pick the shortest path, how to avoid bumping into things, how to avoid obstacles, and how to actually move, whether to use a wheel or whether to use steps. That's the biggest deal, right? So navigation is navigation is one of the sub-objectives of AI. Next is natural language processing, being able to understand human languages. That's the another objective of the AI. If a program is doing the NLP or natural language processing, then we call it then we call it intelligent. Okay, so how to speak a language, how to understand a language, how to make sense out of a sentence, how to speak a language, meaning how to convert a written text into meaningful sound, how to understand a language, meaning given a sound, how to first create text out of it and then understand its meaning, right? All right, so these were, let me answer a very good question from uh, Niharika. Question is, if the AI term was coined in 1956, did it just exist as theoretical concept, or was there any practical implementation of it back then? So the work has been going on forever. Many systems were built, many systems have failed, and some of the systems have become successful now because of data and processing. Okay, a lot of algorithms that were built in 80s are far more useful now because we have computing and we have data. All right. So that's the reason why we are talking about AI now, even though it has been going since ages. All right. So this is one question I want you to take. I'll take your question related to ML very quickly. Okay. And general questions I will take very quickly soon after this. This was something I thought important and very relevant in the context, so I answered it now. Okay. Next, sub-objectives of AI other than representation of knowledge, reasoning, navigation, or natural language processing. Next is perception, being able to see the things. What you see on the left-hand side, what you see in the left-hand side is Kinect. Kinect. This is Xbox Kinect. How many of you have used Xbox Kinect before? All right. Wonderful. Wonderful. All right. Great. Wonderful. So some of you, actually around 100 of you have used Kinect. Great. So basically, what Kinect does is it recognizes the figures in front of it. It uses two things to see the real world. Two things. One is the visual, as in the one is seeing things through the camera. It has the camera here. Second is the second ability it has is to sense the body heat. So it builds the perception based on the heat. Okay, based on the infrared signals from the heat. So that's why it's able to differentiate between you and the sofa behind you. All right. So as you dance in front of Kinect, it recognizes your hand movement and gives you rewards accordingly if you are able to copy the dance on the screen very well. Okay. So it's basically a very good thing, good tool, good system or good gaming console for using your body for controlling various things. So that's the important part. So how do we see things in real world? That's perception. Okay, so trying to understand perception, as in case of Kinect, it's using sound as well as heat, right? Some other systems could use sound, sight, touch, and smell. Okay, they could use camera, mic, or the touch or the smell, or maybe the heat from the body, like infrared signals, correct? So many systems can build the perception about the surroundings using various sensors, all right? So perception is another ability, another sub-objective of AI. Perception is another sub-objective of AI. Okay, it's not alone sensing, but using sensors, using all kinds of visual tools, using those tools, building, using those tools and building the using those tools and building a perception as in, is it a human, is it a person, is it a dog, is it a sofa, or is it a couch, or is it a table, anything, right? Right. So So being able to sense and being able to perceive, there are a very thin line difference. Sense is just being able to know your presence, that's sensing, while perception is understanding what is around, right? That's sensing. Using senses, we perceive things. All right, good question. So I think I have answered that question, Anup, as well. Understanding is a part of AI. Yes, understanding things around you, understanding various things. Understanding is a very big word. So understanding what? is what we are talking right now. All right, good point. Now, so building a perception is something which is a sub-objective. Now, there is a other term. When we think about intelligence, there are many other things that come into play. Like we also think about emotional intelligence. Emotional intelligence like um, loving each other, liking each other, anger, and other things. That's emotional intelligence, right? And the other thing could be creativity. Like there are many people who can create music, create sound, create paint, create um, various kinds of things. That's creativity. Then intuition that you generally have this hunch, this. Okay. So in 1956, what they said was that if we are able to build, if we are able to achieve these five things, if we are able to achieve these five things, the generalized intelligence should be possible. Okay. So being able to do the generalized intelligence given the other five should be very much possible with the algorithm, like the one as we saw earlier in case of our program playing Mario, right? It kind of paused the game. So every time it was about to lose, it was about to lose, it was pausing the game. This pausing the game could be considered as the intuition, or you can say creativity, or you could say this it's emotional intelligence, right? So if you could achieve the previous objective, the generalized intelligence should be possible. Okay, and you will see that the anger, hate, the anger, the like, and the feeling, and other intuition, all of these are kind of combinations of the previous sub-objectives of AI. All right, so therefore most of this could be achieved if the other objectives are achieved. Okay, so we can take a break here. All right, so we can take a break for 10 minutes and back by 9:46 p.m. IST. Okay, you can put the time in your own time zone in the chat window. You can put the time zone in your own window, please, in the chat window, please. All right, so I'm back, everyone. Please raise your hand if you are back. Wonderful, wonderful. So I can see that 15 of you are here. Great, great. I think everyone is back. So let's start our session. Great. So wonderful set of questions. Keep the questions coming. Questions is the only way to learn something. Okay. And as per our study earlier, I have been doing webinar and the classroom sessions for quite some time. And in one of the in earlier, we had run these statistics, and we found that only the things that people asked about, they were the only thing they retained by the end of session. Okay. And no matter what I taught, it was basically their questions that they remember. Okay. So in the similar way, please ask questions. That's the only way to learn something. All right. And that's how our classes are structured. Most of our content will be available parallelly in the self-recorded format, but the classrooms, that the online live classrooms, are for answering your questions. Okay, so do not worry if I'm answering more questions, because most likely the question that I'm answering from somebody would be useful to you as well. Okay, so that's why asking questions is important, and trying to answer somebody else's question is also important in order to learning. Okay, great. So before the break, we had gone through the understanding of big data, understanding of why we need data and intelligence by the way of an example of Mario game, where program collected the data as it went, and and by the end of it, it was able to learn everything by itself. So the generalized intelligence is an output of the other five kind of intelligences. That's what we talked about with respect to AI. So we started with a simple Mario example, giving you a sense of what does it mean by data and AI. Then we went ahead with various aspects of data, like storing data, storing various formats of data, and you storing using various kinds of tools. And then we talked about collecting data before that. For collecting data, we needed IoT, Internet of Things. And then we talked about processing data. Processing could be done multiple ways, using normal processor, using multi-core, using the GPU, or using distributed. So processing could be done in a normal fashion or using a parallel computing. Parallel computing, there were multiple three systems which we compared. And then we talked about Spark in detail. All right, great, great. So there are a few more questions that I would like to answer here. And the question related to ML, I will answer in a minute. Okay, leave it there. Uh, Question is image recognition the same as perception in AI? Yes, image recognition is just one part of AI. Image recognition is just one part of AI. All right. A question from Anup is, without thought, AI is possible? No. And thought is basically what we try to represent in the form of the knowledge, right? Good. A question from Ramesh, how is robotics connected? Good point. Let me just go back here. So if you think about navigate is achieved using robotics. Okay, the mechanical movement, such as mechanical movements, that's a part of robotics. Okay, so robotics is hardware plus computing, right? Therefore, and you'll be amazed to know that a lot of robotics is actually programming. Okay, a question from Naveen: how does AI
perceive hearing or smell using the same sensors, just that it builds the program that is hearing or smelling, it should be able to convert that data, that numbers, into something actionable. All right. Another further point is, can AI be used for security, like going through tons of phone calls in real time? So it's not alone AI that will do it. With AI, we mean the algorithm, the understanding, the knowledge, while most of the work could be done using distributed computing in along with the algorithms. Okay, so yes, and understanding the context of conversation, right? So question is, AI is not a tool. Okay, AI is not a tool. AI is objective here. The way we talked about AI is that AI is objective. Similarly, big data is not a tool. Big data is an objective, right? We have big data tools. Similarly, we have AIs, the various algorithms, hardware and software that are trying to achieve AI. All right. So that's how we can use the term AI in various contexts. All right. So yes. So the objective would be to if we are able to solve these basic problems of AI, we would be able to understand the context of conversation. Or in other words, let me put your question in other words, that understanding the context of conversation is part of AI. Okay, is part of AI. That's basically we talked about natural language processing as well as the knowledge representation. Right, good question. All right, great. Now, how to implement human thoughts on AI? How to implement human thoughts on AI? Yeah. Mm, how we implement human thoughts on AI? Basically, that's what we are doing by implementing AI. Can't AI be manipulated as it's just machine understanding? Yes, it is. Okay. AI is an objective. AI is something that we're trying to achieve. If we are doing something, we can say that we're trying to achieve this part of AI. All right, great. Now we talked about now question is, how do we achieve AI? AI can be achieved by combination of multiple systems, right? To make a machine behave like human, we require multiple kinds of things. You require robotics, right? Like, for example, a self-driving car. We need a way to move from one place to another, as well as being able to steer very quickly and apply brake very quickly and automatically. That's robotics, right? Or a humanoid, a, a mechanical man trying to move from one place to another. That's robotics. Okay. Now, at certain part, you might require rule-based systems. At certain part, you might require domain-specific computing. In order to achieve AI, we might require many kind of systems. We may require many kind of systems. Okay, but machine learning, machine learning is something that's the heart of the AI. Machine learning was invented to achieve AI. Okay, machine learning is a branch of AI that that basically tries to achieve those sub-objectives of AI. Okay, there's a part called deep learning, which is a part of machine learning. We'll talk about it very soon. Okay, all right. So these are the multiple ways of achieving AI. So, so we talked about objectives earlier. We talked about these objectives. We talked about perception, reasoning, navigation, natural language processing, and representing knowledge. These were the sub-objectives of achieving AI. Achieving AI. The definition of AI was very simple. Intelligence exhibited by machines. Now, here, the intelligence and the machines are very subjective terms. The better was to convert it into these five sub-objectives of a bigger objective. All right. So in order to achieve these objectives of AI, we use a combination of multiple systems. Either we use domain-specific computing or we use rule-based partly. Earlier, we only used rule-based, which we failed at. Similarly, we also tried domain-specific computing. That also failed, right? And alone, robotics cannot solve. Therefore, machine learning came into play, whereby, so in order to achieve AI, we might need multiple kind of systems, and we are going to be more focused on the machine learning. Okay. Now, what is machine learning? Machine learning is field of study that gives computers the ability to learn without being explicitly programmed, right? It's the field of computing. It's basically specialized algorithms that give computers the ability to learn without being explicitly programmed. Okay. So for example, in case of the first game that we played, in which there was a program which was trying to learn Mario, and there we did not specifically programmed. We just hooked it till the point we told that this is the algorithm to execute when you receive data. That's the part where we programmed. It's not zero programming. It's the initial part that we did there, but the actual ability to play the game was not coded by us. We did not explicitly write program in order to code it, in order to play it. In order for our program to play Mario, we did not write explicit instructions. We let it figure out. Okay. So, so machine learning is nothing but set of algorithms and techniques, or you can say computer programs that gives the ability to learn without explicitly writing code for every kind of situation. Okay. So it's a branch of AI or a field of study that gives computers the ability to learn without being explicitly programmed. All right. There are many kinds of further, the machine learning is categorized into multiple domains. Okay. Machine learning is classified as supervised and unsupervised machine learning. What is supervised? Given example inputs, meaning telling the program that this is right, this is wrong, this is right, this is wrong, the program should be able to figure out what is right, what is wrong in future, right? For the unknown inputs, it should be able to tell what is right, what is wrong. Okay. An example could be email spam classification. In the beginning, somebody could have trained a program, or you will have to train a program to understand what is right, what is correct email, or what is a spam. Okay, that is supervised learning. Supervised means we know the sample input and sample output. Using that, we are trying to take the future calls. Okay. The second kind of machine learning is unsupervised learning. Unsupervised learning is no labels are given and you have to find a structure. You do not have a data. Your problem is not like that this is the past and this was what we did and now you do the same thing. Not like that. We don't have a supervisor available in case of unsupervised learning. Instead, we are given data and we are told, can you find structure in this? For example, given humongous data, just find outliers. Okay, that's unsupervised. Similarly, a problem like, given these thousands of emails, can you classify them in just 5 different buckets? Okay, that's unsupervised learning. We are not specifying what kind of bucket. We are just saying, just place them in 5 buckets such that all similar emails are in the same bucket. Okay, we are defining the definition of similarity. That's unsupervised learning. Okay, the third category of machine learning problems is reinforcement learning. Reinforcement learning is dynamic environment performing a certain goal. Dynamic environment performing a certain goal, meaning you're in the environment, things are happening, you do something, you get a reward, you do something else, you get a punishment. That's reinforcement learning. The program doesn't really have to keep the entire history of things that have happened so far. It just have to learn from the entire history of past and take action in the present. That's reinforcement learning. So, question to all of you is, out of these three, which one was Mario? Which one was the program playing Mario? Supervised, unsupervised, or reinforcement? Quickly. Yes, it was reinforcement learning. Why? Because it was a dynamic environment. You injected. We did not tell this program what is right or what is wrong. We did not give it the data. We did not play by ourselves in the beginning. We did not play by ourselves in the beginning and showed that these kind of moves are right. These are kind of moves are wrong. We did not do that. We did not do that. Instead, we just injected our program into into this game. We connected our program into this dynamic environment called Mario, and it has to perform a certain goal, like maximizing the score, right? And it has to take various actions. That's reinforcement learning. In reinforcement learning, the next action does not really depend on all the things that you have done in past. It more depends on what are you doing right now. Okay, this is reinforcement learning. All right. So further, the supervised learning has been further categorized into classification and regression, while unsupervised learning has been examples of unsupervised learning is clustering and further analysis. Let me take an example of classification. Let's say you have a huge huge database of emails, right? And you want to classify that database as spam or not a spam. Okay, to classify your emails, first you will have to, you yourself sit down and classify by yourself. Look at the email, mark it as spam or not spam. Once you are done with it, you will have some sample data, or we call it training data, right? And then once we feed this training data to the computer should be able to tell whether a particular email is spam or not a spam. Computer would be able to tell about the emails which it has not seen earlier. Okay, that's called classification. That's called classification. The other example of classification is, for example, image recognition, right? Specifically for numbers, right? Given an image, we have to classify that image into 10 categories, whether it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So given an image, we have to classify that into any of these 3 buckets. Okay, any of these 10 buckets. That's here we were classifying an email into 2 buckets. Okay, so based on past history of emails, the program will learn to classify the emails into spam, not spam. Similarly, given the past history of humongous corpus of data, such as there is a data called MNIST. MNIST is standard data that we use for image classification. So here we are trying to classify the image. This is a hand-drawn image, and we are trying to classify whether it's 0, 1, 2, 3, 4. So here this one is having 10 categories. All right. So the image recognition is specifically with respect to character recognition. It's kind of a classification problem. Okay. Now, we generally solve these problems using logistic regression, or there is something called softmax, which is an extension of logistic regression. Okay. So we use logistic regression in these cases. The other form of supervised learning, other example of supervised learning that we took earlier was regression. What is regression? Regression is the answer should be a number, not a multiple choice multiple choice answer, right? So if the way you can think about the way you can figure out whether something is a regression or a classification. In case of classification, it is more like objective type question. You have to given a question, given an email, you have to say either spam, not spam, right? That's classification. Or given a character, the program has to tell whether it's 0, 1, 2, 3, 4, 5, up to 9, right? 10 choices are there. But in case of regression, it's not an objective question. It's kind of a fill in the blank. Okay. So how does it work? Imagine that you have the data of the salaries versus experience, right? Given some salary, you have got some, sorry, given some experience, you have some salary. For example, given say given say 1 years of experience, you have got some salary. Given some more years of experience, there is some salary, and so on, right? Further, there is this has come down. But the objective of this kind of machine learning would be to be able to predict, to be able to tell what would be the salary given the number of years of experience. Okay, so first we will feed the data of the past. We will feed the data of salaries of various people, and then we will let this program predict the salary based on experience. All right, so predicting a continuous value attribute associated with an object, that's just too much words. It only means that predicting a number, predicting a decimal number is the objective of regression based on the past data. All right. So the general strategy, general solution to regression kind of problem is we have one of the very commonly used one is linear regression, in which what we do is we keep on drawing these lines. We keep on drawing these lines, and we draw all possible lines. Okay, we draw all possible lines and figure out which line is the closest to the actual data. We draw a line and we find out how far is it from all the points. We sum up these distances and then try to find out which line is closest to all these points. Okay, which what is that line which is best fitting these data points? That's what is regression. There are many techniques to do the regression. So here I'm trying to show you that we are trying to draw all possible lines and and then trying to figure out what's the best fitting line, right? Now in this case, if we just blindly try all possible lines, even solving even solving a simple problem like this would be impossible, right? First, you will draw all the lines from this point, then this point, then this point, then this point, and then at all angles, as well as at all the distances from the origin. So we'll keep on drawing all possible lines, which will be impossible to solve in reasonable data, right? Right? Therefore, there are many techniques involved, and you can guess from this that if you are just blindly drawing lines, you will require humongous amount of computation. We will first draw the line to compute the distance from all the points, and then
compare the distance from the previous point, we ignore the previous one and keep this one if this one is better, right? And that's what we keep on doing over and over again. So you don't require too much of memory in this case, but you require humongous amount of computation, humongous amount of mathematical computation, and that's why we generally use GPUs in such kind of scenarios. Also, the problem goes further more complicated in case of regression. Similarly, the case with the other algorithms. So we keep on trying all possibilities and trying to figure out which model. Here, the line is the model. In other cases, it could be something else. Which model is fitting our data, right? So that this model can predict the future. This line that we are drawing here is going to give us give us the closest. It's going to this line that we talk about here is the model, is the one that's going to give us the predictions in future. All right. So this is linear regression. Now, to optimize these regression kind of problems, brute forcing or trying all permutations is almost impossible. Therefore, instead of trying to draw all the lines, you go into the direction. You go into the direction which is giving you the maximum advantage. Okay, you drew a line and then you drew another line and then you compared that, am I going better or worse? If I'm going better, we'll just move in the direction. Okay, so that's the strategy. We call it gradient descent. Imagine yourself blindfolded on a mountainous terrain. Imagine yourself that you are blindfolded and you are standing on a mountainous terrain. You are not on a flat one, not like you have to spot a gutter, but it's a mountainous terrain. It's a continuous terrain. Okay, so you have to imagine that you are blindfolded and on a mountainous terrain, and your objective is that you slightly walk, slightly walk in all directions and try to figure out which which one is your objective is to find the lowest point. Your objective is to find the lowest point. Okay, so what you'll do is you'll take a step, and in case your step is going down, you further move forward in that direction. If your step is going up, you turn around exactly 180 degree, 180 degree and move in that direction. If you're if your objective is to just go to the lowest point, what you will do is, because your eyes are closed and you don't know what's around you, right? The only way you can figure out is by stepping a little. And so you step a little in one direction and then try whether you're going down or up, right? If you're going down, that means you have to go further that side at a faster rate, and then again to keep on doing the same thing. All right. So what you do is you change the line's slope or the line's location, and then you see whether you are going better or worse, exactly the way you would do in case you're blindfolded. And this is called gradient descent. Okay, so you go faster in the direction where you're doing good, you go in the opposite direction if you're doing bad, right? So this is the gradient descent way. It's basically a greedy way of finding the results. All right, so this is basically optimization. Instead of trying all permutations, you do a little bit more greedy approach in order to find the solution. You may not be able to find all possible solutions, but you'll be able to find the solutions which are closer to you. All right. Now, next is clustering. One of the types that we discussed about machine learning was unsupervised learning. In unsupervised learning, what we said was, in unsupervised learning, we have to find a structure in the data. We are not given that, do not have a trainer. We don't have a supervisor. It's completely unsupervised. We are just given the data and our program is supposed to find some structure in it. The structure could be that find three groups of people out of these people, okay, based on heights or maybe based on various criterias, or the objective could be draw a hierarchy. Draw a hierarchy like in creatures or in living beings. The Darwin drew the hierarchy, right? That humans and monkeys are very similar, and they are very similar with the other animals, and further. Similarly, drawing this hierarchy is also a part of unsupervised learning. It's called hierarchical clustering. This is called k-means clustering, where we put things in buckets. Here, let's say you're given the cars of all the world, cars manufactured so far, right? If you're given all the cars and your objective is to classify them such that the cars that are coming under the same parent, right? Here, cars which are in the same node are very much similar to each other, okay, as compared to this and this. So creating this hierarchy is also unsupervised learning, and this that's called hierarchical clustering. So second part of machine learning was unsupervised learning, right? Unsupervised learning. And unsupervised learning could be clustering, and clustering could be example of unsupervised learning is clustering. Example of clustering is k-means clustering and hierarchical clustering, and there are some more clustering examples as we go ahead, right? Right. And the reinforcement learning is the case like Mario, the one where we started. All right. So before we jump further into the neural network, so I would like to take a look at your questions. All right. So now the question is how ML is different from AI. I hope that is answered now. ML is nothing but a way, a tool, a technique to achieve AI. ML is a branch of AI so that we can achieve the AI. Okay, so that's the subtle difference. So everything we do in machine learning, if you look at the Venn diagram that we talked earlier, everything that we do in machine learning is part of AI. But everything that we do in AI is not necessarily machine learning. For example, if we are doing something here in robotics, right? And like we are just focused on the navigation, it may not be part of the machine learning. All right. So we can't really do the interchanging. Great question. What is the first stair to go to AI? First stair would be to learn machine learning and then rest. Okay, first stair would be to first learn the normal programming language, learn to do the normal kind of processing of the data, and then learn machine learning and then the rest. Okay, what are the prerequisites subjects known for AI? Please advise. What? Yeah. So so instead of this way, I'll talk about specifically machine learning. So we are launching a machine learning course. We have actually launched it already, and for that we would require people to know basics of a language. Even though we are going to cover basics of programming language in Python, so we are going to cover Python in the course. It's a humongous course. The only thing we would require is the bit of maths knowledge, like the knowledge of the maths of 12th class. Okay, that's all. Okay, the course is going to be very hands-on. We're going to focus like unlike this today's class, the course is going to be very hands-on. We are going to do before talk. All right. This session is designed for people from all kinds of backgrounds. Therefore, I'm talking a little more than you should be. Okay. Question is, can we call reinforcement as unsupervised plus a feedback loop? We can call reinforcement as supervised plus a feedback loop. All right. Good question. Good question. Okay. Or maybe unsupervised also because you don't have a data upfront. Okay.
But basically, you keep on getting data instantaneously, which gives you the feedback loop gives you the instantaneous data about what is right or what is wrong. So basically, feedback loop gives you the classification of the record. Sorry. All right, sorry. I think I clicked on answer somebody's question. Okay, so I hope. All right. So a question is for reinforcement learning. For reinforced learning, we will need to define condition or situation where we lose points or gain points. Yes, the environment would give you those points. Okay, the environment, you'll have to write the program to extract the reward or the punishment from the environment. That's very good point. Thank you, Prakash. Can you give us an example of regression is similar to Mario for reinforcement? Can you give us an example of regression which is similar to Mario for reinforcement? Good, good. So uh, in case of regression, right, what we are trying to do is we are trying to figure out a value given some past data. Imagine this, that there is a factory. There's a factory which has certain output. Okay, imagine there is a factory which has certain output, and what we have the history of that factory, that this was the input, these were the various temperatures, these were the various inflows of various chemicals, and this is the result we got. Okay, now given the input parameters, can we guess the output? Okay, so it's not as friendly example as Mario is. The other friendly example could be that let's say we are trying to compute the prices of real estate of our house. Okay, that's the case. That's the example that we're going to take in the class. Okay, and that's where we will start our course. Okay, so given the prices of flat, prices of real estate, uh, as well as the area of the flats for which we know the prices. We also know we also know their locality, like how populated is the locality. And based on this data, can we predict the price of a real estate for which we don't know the price, but we know the other criterias? All right. I hope that I was able to answer, Guru Swami. A question from Rick. What is the content of AI apart from ML and DL? As you can see in this diagram, the other content of AI is robotics and the normal usual programming languages, along with rule-based systems that we call expert system, which is that's what we did earlier before we built AI. We built machine learning. Before that, people actually did rule-based systems. So still, we do a lot of parts of it using rule-based systems. For example, let's take a case of Alexa or Google Voice, right? So in that case, they try to do a lot of things rule-based, okay? Rule-based, and part of it is based on machine learning. A question from Harkaran. Can we solve spam anti-spam in an unsupervised manner, that is, without training the model and hoping it segregates the two samples into two categories, hopefully spam and anti-spam? Maybe if let's say we do it, let's say we do k-means using two buckets, okay? K-means clustering. We talked about clustering, right? Where we create n number of buckets, that's called k-means, okay? So we create certain kind of formula that finds the distance between the two emails, and based on that distance, it creates those buckets, okay? So hopefully we might find the spam anti-spam, but there is no guarantee, all right? A question from Bukas. For the game of Mario, I believe we must have defined the condition or situation of gaining and losing point. do it similarly with supervised learning. We have not defined a condition. Environment is giving that number. Okay, Mario game was giving that number to us and we were just extracting that number. So we were not providing the data which is earlier coded. Okay, in case of um, in case of the supervised learning, we have the previously created data. All right. Venkate is saying, please provide real-world example of domain-specific computing and rule-based systems. So rule-based system, as I told you, some of the Alexa or Google Voice, where they have written a kind of rule structure that if the keyword is this, then do this. If the structure looks like this, then do this. That's kind of partially rule-based. Okay. As well as specifically like domain specific computing, like earlier people doing Lisp and other things in order to achieve AI, they are also partially used at various points. Okay, a question from Santosh is how to make graph in 3 variables in k-means clustering. In clustering, we don't create graph. Instead, we create the buckets. Okay, let's say here we are trying to put things in 3 buckets. Let's say given all the emails or given all kinds of creatures on the planet, we want to just put them in 3 classes. Okay, class A, class B, class C. And just that we will have to define the criteria of distance between the two, like between me and you, or between me and a cockroach, like how many hands they have and how many right, size of the body and everything. So that'll be the distance between one creature to another. And based on that, we could do k-means or hierarchical. Wonderful questions. When we write ML algorithm using Python, we should code based on these principles like classification, regression, and reinforcement, or so very good question. Very good question. So the way you do is that first you look at, let's say, first you know the algorithm, you know basic languages. Once you know that, the general strategy would be first understanding the problem that we are trying to solve. Understanding the problem is very, very important. Okay, understanding the problem that we are trying to solve, and then based on the understanding you figure out which one algorithm or multiple algorithms that you're going to use, and then under each class of algorithms there'll be multiple cases that you will have to keep on trying. So that's why we're going to cover an entire 2-hour session on figuring out the problem, uh, figuring out the strategy given a business problem. So that's the last session that we are going to take in this class. All right, good question. And we really understand the value of this. It's a hard thing to figure out which strategy to use. And that's where most of the data scientist time goes. Okay. So the truth is in industry, 90% of time, 95% of the time of a data scientist or a machine learning engineer goes into data cleaning, right? I can tell you based on my experiences at InMobi, while we were trying to build, we were basically doing not this, we we're basically doing some form of recommendation engine that we'll talk about later. So we were doing basically recommendation generation kind of classification problem. So, or regression problem or combination of both. So at InMobi, we were trying to build the recommender engine. There, figuring out that these are the algorithm that we are going to use and these are the coefficient was a hard thing that we had to do various kinds of things. But that did not actually take our most of the time. 90% of the time was gone into processing the data, right? Because we were we were trying to handle 200 terabyte of data, and that's actually a huge data. Very good question. All right. A question is from Santosh. What is the difference between k-means clustering and k nearest neighbor? Which one is more efficient? All right. So k-means clustering or k-nearest neighbors, they are actually very similar algorithms, and both have very similar algorithms. So we can discuss it more. Maybe I can write to you in a separate email. All right. Or you could come over to our discussion forum. Please ask there. I would love to answer that question there. All right. Thank you. Very good question. Question is, could you go to the slides of type ML, slides of types of ML, and how to achieve them via the several means like clustering, regression, etc. Yes, you can see that now. So these are basically the classes of machine learning. There are a few more as we go ahead. There are a few more in these buckets. All right. Here, this is very, you can see that it's a very big overview. All right. All right. Is that the one you wanted to ask? Great. All right. So this was about, so we talked about that the heart of the AI is machine learning, and we talked about machine learning, like what kind of machine learnings are, basic structure. Then we talked about what is classification, what is regression, and for optimizing regression, we use gradient descent. We'll go into more closer way of implementing regression in the during the class, and this is where we will start our course. All right. And then we'll further as we go ahead, we'll talk about these other algorithms. Now, the most important part. Now, most important part, why are we talking about machine learning? The algorithms like linear regression and all of these algorithms are from 1940s, even older than that. Linear regression is nothing new. Solving equations or trying to draw a line is not a big deal. We have been doing since 1800s, right? What is important today that has changed? The reason why we are discussing it today is the neural networks. The neural networks. So many things were tried in past, and most of these things did not yield results. After definition in 1956, somebody has asked, after definition in 1956, many different strategies were tried, computing, rule-based systems, and so on. But none of those actually gave intelligence. None of that actually brought in intelligence, right? But lately, the neural network, building an algorithm, building a software which kind of emulates the human brain, has been very successful. I'm going to give you a quick demo. All right, I'm going to give you a quick demo of NN. All right, so as we talked about, the artificial neural network is the computing systems inspired by biological neural networks that constitute animal brains, not human, but all animals. Okay, so it's a branch of machine learning which deals with trying to build systems which try to emulate the animal brains. All right. Now, all right. So what they did, if you think about human brain, it has basically the, all right, somebody has raised a hand. You can ask a question if you have, please. Luis, Milan, and Reddy, and Rex. Okay, if you have question, please ask using Q&A window or chat. Okay, so let me go back to where I was. All right, so neural network is something that has happened recently, 2006. Uh, Certain engineers at in Australia, they were able to successfully demonstrate that it's not linear regression that's able to solve their problem. It was the neural network. One of the strategies, just like linear regression, you can think of it, or classification, uh, it's similar to that. So what they found is that if you create a network of individual units of logic, okay, you will be able to create intelligence. You will be able to predict many things, right? In case of linear regression here, what if our data looks like complicated? Where did it go? Where did it go? Yeah. Here, we were pretty happy that our data was kind of linear looking. What if the data was really complex? Data was really complex, or we could not predict the future based on this linear data, linear line, right? And many situations cannot be really solved by using linear regression. And in recent times, it has been proven again and again that artificial neural network can solve the problems. Meaning, each individual units is nothing but taking input, giving output, and multiplying it by something and adding something. And these all all of these units that you see here, they have an input and the output, right? Output is generated by multiplying a number and adding something, doing some calculation, and that numbers is something, these all the nodes are improving all the times. Okay, as we give it more and more input and output samples, it figures out these coefficients, all of these things figure out this, what to multiply with, all of they figure out their numbers. Okay, and this way, when you arrange such units, such small programming units, such small mathematical units, these are mathematical units which take a number as input, give out another numbers, and multiply it by something, and reply and add it by something. So this is what these all the machines are doing. Okay, all these nodes are doing. So if you think about it, in the human brain is a complex connections between the neurons. Individual neuron is a dumb unit. It doesn't have, it is not really very intelligent. Individual neuron is, it takes the input signal and gives the output signal, multiplies it by some coefficient. Okay, multiplies it by some number, which call it, we call it bias. Okay, so that's what every neuron in your brain is doing right now, taking input signal, multiplying it by something, and producing output. Okay, so combinations of so scientists figure out that if we layer multiple neurons one top of another, we create these layers of neurons, we would be able to create a human brain kind of unit which takes input and gives output. Okay, first it will learn based on input output, and then learning means they will all figure out their coefficients, and then will be able to predict the output. All right, so learn means progressively improve performance to do tasks by considering examples, generally without task-specific programming. Example could be based on image, say it's a cat or not a cat. All right. So the output is yes or no in case of cat, image recognition, whether something is a cat or not a cat, and the input is the whole image, the whole data of the image. So So a neural network is nothing but connections of the various neurons. And deep learning neural networks is basically having multiple layers of hidden network. So when we talk about artificial neural networks, there is an input layer, the one which gets the input from us, from the from your model, from your input data. And then there is an output layer, and then there is a hidden layer. Okay, hidden layer is again similar to this one. It's just that this is not This is not something that you are feeding your data to. All right. Now, if you have more than one hidden layer, this is called deep learning neural network. Using the algorithms like backpropagation, backpropagation, we basically build all the coefficients of all these based on input and output, and then we utilize this network to predict the output. Okay, so basically we use this kind of algorithms when our usual approaches are not really applicable. Usual approaches like linear regression or other form of regression or logistic regression for classification or mm, classification or predicting a value. Okay, if that does not work out, then we chain the multiple units and we call that neural network, and we use this technique to predict the output. All right, and basically the deep learning this is called deep learning when you have multiple hidden layers. Okay, so it can be used at a various places. It can be used at various places. It is right now being used by many. For example, BuzzFeed is using deep learning today to predict various articles to show you. Airbnb is using deep learning in order to predict prices. Optimizely is also using deep learning in order to show you the best variation, okay, or optimizing your website. Similarly, the face recognition systems from Google, for example, is trying to figures out which one is a face in the photo or who is there in the photo. That's image recognition or facial recognition is being used by Google. And in your Google Photos, if you are figuring out the characters in the images, similarly, they are using the deep learning for the translate, Google Translate. And we have Pinterest is using deep learning for finding similar images, while Facebook is using deep learning to compose the auto reply bot. Okay, so there's a humongous research right now going on, and a lot of systems are based on based on the deep learning as of today. For example, when you use Gmail or when you use, say, um, Inbox from Google, both of them have auto reply, right? It suggests you what to type. All of these systems are mostly based on based on the deep learning. A question from Rake says, you were mentioning regression, classification, etc. in ML. Are these layers in deep learning, deep neural networks, replacement for those in machine learning? Yes. When those algorithms do not yield great results, the deep learning is able to give you great results. For example, deep learning is able to reach that character recognition that we talked about in classification. It's able to reach a very high accuracy in that example. Okay, in the MNIST example, the character recognition one, it's able to reach really great accuracy. All right, so even though machine learning is as old as your maths, okay, but deep learning is also kind of, a couple of decade old, but now everything is possible. Now it has been proven by the leaders that it works. It has been proven that it works, and it has been proven to work on the data that we did not think it will work on. For example, image recognition, voice recognition, the translation of the language from one to another. All right. So, a question from Harkaran is, are there any drawbacks of DL? Is it computationally expensive? Yes, it is computationally expensive, and we use generally the GPU based systems, or we use we had to redesign a lot of new algorithms to work on the GPU and processors, right? So that's the deal here. Now, here are some more examples of how many of you have used auto draw. In auto draw, you just draw something and it auto completes it with suggesting you all kinds of diagrams. Okay, and in Google Translate also. So all of these tools, as of today, are using deep learning. Now we're going to demonstrate to you how it will figure out the how it'll figure out the various pattern here. Okay. All right. So here what you have is, okay. So what we are trying to do here is we are trying to form the neural network. Okay. This is the input side. This is the output side. And here are the other neurons. So this is the layer. Okay. All right. So imagine that you have this kind of data, and what you want to do is you want to draw a line, or you want to separate things. Okay, this is the output you got. Okay, imagine that your role is to draw separate blue from green. Okay, separate blue from green by drawing a line or something. Okay, your purpose is to cluster this data. Now if you go with k-means, we can't. Okay, we can't really cluster this. Similarly, if we go with any other way, we won't be able to do it. Okay, therefore, most of the regressions generally fail in these kinds. Okay, but if we use, say, a deep learning algorithm, we will be able to figure out, it'll keep on drawing all possible lines and trying to figure out that how should it draw it such that the two are separated. You can see that it has separated the blue from green, right? You can also give it a try. I'll give you the URL and you can give it a try. Okay. So what we are trying to do is we are taking a simple problem of classification. We are trying to classify the words. Okay. We are trying to classify the colors based on certain certain what do you say, certain path or line or a circle or a closed loop. All right. Let me give you the, so you can go to playground at TensorFlow and try it out. Okay, so there you basically can pick up any kind of data and then let it classify that. Okay. All right, let me just take some other like this and let it again try to guess where is the line. See, it's evolving to draw the, segregate the data, cluster the data, right? This one is harder, and let's see if we would need more neurons here. Um, All right, it'll take a long time here. It's trying all possible things in a very clever way so that it can separate things. Okay. All right. It's going to take a while to draw something out of it because there is not a straight pattern. All right. All right. I do not have the code for this right now. Okay. But yeah, we will definitely share the code over the GitHub repository. All right. That's the point. Great. So what are the frameworks for deep learning? Now, your question could be, then what's the point? Well, why are we needing the new frameworks? Can't we do the same thing using our existing programming language? We can, but Since it's computationally intensive, there was a need to use multiple processors, multiple multiple cores of a GPU. Therefore, newer frameworks were written, and the frameworks like TensorFlow, Theano, Keras, and Caffe, along with PyTorch and Torch, these are the various deep learning frameworks. We are going to focus in our class, in our class, in our class, we are going to focus on the TensorFlow. Okay, we are going to focus more on the TensorFlow because TensorFlow 1, it has got massive adoption across the globe. It is well supported by Google as compared to the other tools, and it has proven itself to be very efficient and is being used by many companies. So we are going to focus on TensorFlow. We'll use TensorFlow framework in this class. We will not only use TensorFlow on one computer, we will use TensorFlow in a distributed way. Okay, so because TensorFlow is probably the most complete solution for deep learning. Even though creating your own algorithm in TensorFlow could require a lot of work, but still, to use it, it's actually very simple. You can use TensorFlow from R, you can use TensorFlow from Python, but we are going to use Python and TensorFlow. Python for usual tasks, scikit-learn for usual machine learning, and for TensorFlow for deep learning and other frameworks. All right. So machine learning, we are going to use Spark MLlib plus scikit-learn, mainly scikit-learn. Only few examples will run through MLlib when the data is really humongous. In those cases, we will use MLlib in our class, and scikit-learn is something that we are going to use throughout the class. Okay, and then under scikit-learn, we have some simple algorithms that for that we are going to use pandas. All right, and yeah. So there are many machine learning courses across the internet. There is one from Coursera. Then there is we've also started. We have launched a machine learning engineer course with Python, and which is probably the humongous course and humongous course, humongous course. It's around 86 hours. 85 or plus hours, okay, from hours, and it's going to be live. And the approach that we are going to take is we're going to start with hands-on, and then we will go back to theory and try to understand what we just did. Okay, so that's the approach that we are going to take, and that's the approach that will differentiate us from others. Our course is going to be very engineering focused, very focused towards the application of the machine learning, and very hands-on. Therefore, we are going to launch the Python course before that, along with we will cover in a separate course the linear regression, the linear algebra, maths, and other parts in part of foundation course. Then we are going to go to usual machine learning, and then we will go to deep learning. Question that arises very common is, why are we teaching machine learning when deep learning is doing everything? Why are we teaching traditional machine learning if deep learning is doing everything? The answer is that in deep learning, you require knowledge of the basic techniques. So you can't really do deep learning without the knowledge of machine learning. Okay, I'm going to take you quickly through the course thing. Okay, so it's still running, you see, it's still running. It's not able to yet figure out a pattern there. Okay, so all right. So this is the specialization course. Okay. It has three parts to it: the foundation course, the machine learning course, and deep learning course. You can take a look at the topics here. Okay. As part of the foundation course, we're going to go with the Linux basics. Then we will understand all aspects of, say, how to use on CloudxLab, how to use Jupyter, how to we'll spend a lot of time on Python. Then we will cover the basics of algebra, linear algebra, and then all other tools like NumPy, SciPy, Pandas, scikit-learn, and WoppleWabbit, along with the Spark MLlib examples. Afterwards, we are going to, once that finishes, then we will start our usual machine learning course. Here we will cover the, the introduction, regression, k-means, and everything that's part of the machine learning. Okay, all of these classes will start with a proper example that we will first do the example, then we'll learn the theory back. Okay, then we will go with deep learning. In deep learning, we'll cover everything. In the reinforcement learning, we will try to program what we have taught today. The Mario kind of example, we're going to do it in the class. Okay, that's part of reinforcement learning that we'll do. Okay, so other than that, we are going to take a comprehensive project so that we will be able to learn the entire objective. All right, so this is the course that we are going to we have started, and stay tuned. All right, stay tuned, and we will keep you updated. All right, so any questions you have for me, all of you? We still have around 3 to 5 minutes. So the thing that we learned today is what is, why do we need machine learning and deep learning, and what is AI. We also learned that AI is not a technique, it's basically an objective. We also learned that machine learning is a core area that we will be focusing on. And part of machine learning, deep learning has proven itself great, but is still it's difficult to do the computation. And we also learned the importance of being able to process the data. Remember that every machine learning project or every machine learning work has 90% of time dedicated for data cleaning and data processing. Okay, so you should be comfortable with taking humongous data in terabytes and then cleaning it up, converting into a few gigabytes. Okay, and then applying all kinds of machine learning. Great, great. So it was very great set of questions from you. I enjoyed session. A question from Jeffrey: how is CloudxLab course different from Coursera course? So it will be live like this, and we have our own lab set up dedicatedly for our course, designed and created for it. And it's going to be very engineering oriented, not only the science oriented. So we are going to focus entirely in Python and TensorFlow. So that's the differentiation. Thank you, Paul. A question is, can you explain black box methods for neural network? Yes, we'll cover most of these during our course. Okay, such as back propagation is one term that I used in terms of neural network. We will talk about those in details. Okay, okay, great. All right, I enjoyed your questions, and the way we learn is only by asking questions and doing hands-on, and that's our focus. So all of our chapters from next chapter onwards are going to be very, very hands-on, as in we will start with an exercise. I know that you will find it very awkward in the beginning, and from my experience in past, what I understood is that even if you know nothing about thing and I give you a hands-on to do with me, all of us doing the same thing together, that would that would essentially make you understand half of things. You will infer things by yourself, and then you will ask a lot of questions, and then that's how you will learn. Okay, so in my past experience, that's the way you can learn. A question from Prakash: does CloudxLab provide certification? We do provide certificate of our course, provided you finish all the exercises with us. We have the assessment system in place at CloudxLab because we have a lab, so that anything you do on the lab, we can assess. And with the project that we give, you have to do entire thing on the lab. So we would know that you have done it, and once you're done with it, you will get a certificate. All right, great. Thank you, Alok. I'm happy that you liked it. And question is there any prerequisite for the course, or even a newbie can start and learn with the course? If you had your a little bit maths in 12th, like a bit of algebra, you will be good to go with this course. Okay. And yeah, this course is going to be for the people who have basic idea about computing. They should be and a basic maths. All right, that's the prerequisite. Okay, how much it would cost me if I want to do a data science course? We are yet not launching the data science course. Okay. A question from Santosh: can we use R in deep learning? Very good question, Santosh. So yes, so TensorFlow has a binding for R, which means from R you can use TensorFlow and get your work done, right? Remember that TensorFlow is in C++ and Python or R, you will get the same performance because the work will be done on the TensorFlow side, not on the R side. Okay. Okay, great. A question is, all right, great. All right, wonderful set of questions. I enjoyed the question, and during every class, I learn from the questions, and that's the great thing about these sessions. A question from Santos is, so once we clean data in R or in TensorFlow, so yes, so you will basically clean your data using R and then use TensorFlow to do the machine learning on it. All right. All right. A question is how to change career path from software developer to big data developer. Okay, I would say that you take up a course and maybe do a certification for the big data developer, and that should be good. All right. Thank you very much. It was great questions. And yeah, question is, do we prepare for data science certifications like DS 700? We need to look at it. We haven't thought about data science yet. Okay, but 90% of our content actually covers these certifications. We just need to see what we are missing there. Right? Good question. A question is, yeah, I missed the question, Santosh. My last question is, I'm a Hadoop developer. How is good for me as I'm working also in R for data analysis? Okay. All right. So I'll explain to you. So if you are a Hadoop developer, that means that you are through the data part. As I was explaining that you are going to inevitably work on the machine learning if you have data, right? So like, for example, when I joined InMobi, I joined to do their big data processing for their heavy lifting of the data, right? But the moment I started the work, there was other person who was working with me from the machine learning side, who was a dual PhD who was working with me. And then while working with him, I realized that the better way would be to just learn the entire thing, to just learn the entire thing. And that's how I got moved into the machine learning career by working with by learning the second step. I knew about big data. I was good with computing and algorithms. I was able to move to the machine learning career after working in this way, after learning it was, because the point is that if you are handling big data at a humongous scale, at one point or the another, doing machine learning will become inevitable part. At that point of time, you could either choose to ignore, or you could learn it. And in my case, I'll explain to you further. So in my case, since I learned the entire thing, so I was able to optimize and do things which the data scientists were not able to do because they were not really engineers or software developers. Therefore, I could see the various points of optimization because I learned the machine learning part as well. Okay, thank you. Good question. All right. Great, Santosh. So you could give it a thought. And the course that we're designing is basically thinking from the software engineer perspective. The objective is that most of the engineers who are good with the programming and the algorithms are who are good with engineering, they should be able to do machine learning. Okay. Yes, that's the way you can. So we can summarize it like this: Spark for big data processing, and machine learning coupled with deep learning is for inferring the complex information. Our question is, will it be required to know Python and R or any programming language will suffice? We are going to teach you Python as part of this course, but you can choose to skip that section if you are comfortable with it. Okay? All three parts of this course are going to be separate. You can choose either one or all three. It's up to you. A question from Venkat. So is it like ML requires big data and data science? So kind of, yes. That's a good question, Venkat. It is like ML requires big data and data science. How? So when you have a humongous data, I'll explain to you again with from few things. So let's take a case of Amazon's recommendations, right? So Amazon's recommendations need two parts to it. One, being able to take petabytes of data and cleaning it up in the form of user ID, product ID, and how much they like it, right? That's big data part of it. While data science part of it is being able to figure out how to produce the metrics. Okay, for data science, you might have to use machine learning techniques or analytics technique. That's up to you. All right. So yes, great. Question is, how can I become a good data scientist? To become a good data scientist, you should be good with maths, good with computing, and good with machine learning and deep learning. Okay, and of course, the analytics. So that's the definition of data scientist. And do not forget that you would have to know the domain specific knowledge as well. So yes, being a good data scientist is really hard, but but the most of the knowledge of computing, knowledge of a programming language generally helps you a lot in these domains, along with the say algorithms. Great, very great set of questions. I thoroughly enjoyed your questions, and stay connected with us. And I mean, we do hold these free sessions, and also, we have a lab running, which is being used by many people. And the lab is for people who are trying to learn anything, whether machine learning or big data or data science, anything is possible on the lab. So you don't have to set up your own tools. You can just use the lab off the shelf. Okay. All right. So this is us. Okay. Hardial's question is, how can I become a good ML expert? I would say that whatever topics we have listed, just go over those. You learn those topics, and that'll make you a good ML expert. All right, trust me. We have done a pretty good research on this, and we figured out that these are the topics that are needed in order to become a good expert at the machine learning. Great, wonderful set of questions. I thoroughly enjoyed your questions. I look forward for your participation in on our forum as well. We have a forum at discuss.cloudxlab. So come over there and Okay, if you are, and we have also launched a free session on free course on Linux and other. There are quite a few free courses part of this. Okay, part of our previous course. Okay, so there are you'll find quite a few free sessions here. Sure, the video will be shared with everyone who has attended and also will be made available on our blog. So I'm looking forward for your participation on either come over and learn here or come over to our discussion forum here, okay, or come over to the lab, okay, so or take up a course, all right. So that's what we do, and we also take up the industry projects on the pro bono basis. If you like to connect with us, get your industry problem solved, we can help you. Right now, also we are helping a couple of companies along with our team. All right. All right. So thank you, everyone. It was wonderful to have all of you in the session. Stay connected. I am Sandeep Giri. I have been teaching people for quite some time. I worked with Disha and other similar companies and Amazon and Mobi. Okay. So stay connected, and if you have any questions, feel free to come over to our discussion forum. We frequently answer questions there. All right. Great. Great. Thank you, everyone. I'm going to hang up now. Feel free to reach out to us at support@CloudxLab, or sorry, reach us at CloudxLab. Support is will go only to technical people, while reaches would go to everybody. Okay. All right. Thank you, everyone. I look forward for your more questions, and see you at CloudxLab. Come over, try out a few of the exercises, and that's the only way to learn. Bye bye. Have a great week ahead. Bye bye.